This is going to be one of the most action-packed, filled with learning videos that I've recorded in a while. Not only am I going to teach you everything you need to know about linked list, but also we're going to cover testing best practices so you can write tests for your linked list, also test-driven development, and most importantly, best practices that you can follow, which will make creating your own data structures and algorithms so much easier. So let's get started now. Welcome back to Web Dev Simplified. My name's Kyle, and my job is to simplify the web for you so you can start building your dream project sooner. So if that sounds interesting, make sure you subscribe to the channel for more videos just like this. Now to get started, I briefly want to explain the concept of a linked list because we need to understand this in order to actually implement a linked list on our own. So the idea of a linked list is essentially it's an alternative to an array data structure. So normally when you have an array, you know that you have a list of objects, and each object has a particular index in that array where it belongs. Whether it's index 0, 1, 2, 3, it's going to be somewhere in that array, and that array has a set length, and it's going to be all of the items in the array that make up that length. So you're pretty used to how arrays work, so I'm not going to go too in-depth on them. Linked lists, on the other hand, are quite a bit different. They don't actually have indexes where the elements are supposed to be stored. Instead, each element inside the linked list, for example, this singly linked list, each element is going to have its value, just like in a normal array, but also it has a reference to the next element in the list. So you start with your head element, which is your first element. This is the same as your 0 indexed element in an array, and it has a value, and then a link to the next element in that linked list. And that is going to have a value as well as a link, and so on. And this second element here is essentially the same as your second element in an array. Same with the third element, that's the third element of the array, and so on. All the way till you get to the end of your linked list, and then you're going to have a value, but there's no reference to anything because there's nothing else after this. So essentially in a linked list, you're linking together all of your elements by referencing whatever the next element is. Now, there's an alternative type of linked list, which is the doubly linked list, and it is just like a normal linked list, but you also reference the previous element. So this first element is going to reference nothing as the previous element, because it's the first one, and then it's going to reference our second element as the next. Our second element references the first as the previous, and the third is the next, and so on all the way down to the last element. And then finally, we have a circular linked list, which is just like a single linked list, except for your last element is going to say the next one is referencing the first. So if you were to loop through this, when you got to the very end, you would start back over at the very beginning. Now for the purposes of this video, I'm only going to cover the singly linked list because going on doubly and circular linked list just adds more complexity, which doesn't actually help you learn how to implement a linked list and what the importances of a linked list are, because they're just additional things on top of a normal linked list. And if you know how to implement a normal linked list, implementing a doubly linked list is essentially exactly the same. But before we jump into the code, I want to talk about why would you even use a linked list? I mean, why not just use an array? They're built into JavaScript, they're built into pretty much every language, and they're way easier to work with. Well, the reason is that with linked list, you have certain efficiencies that you don't have with normal arrays. So in a normal array, if you want to add an element, for example, to the beginning of the array, if you want to add an element right here at the very beginning, well, what you have to do is you have to take every other element in that array and push them down one further. So you have to move every element in your array one forward and then add the new element. So that's going to be essentially a big O notation of n time, because you have to loop through every element in the array and move them forward. While with a linked list, this very first element, all you have to do is create a new element and reference the next value of that element as the old first value, and that's constant time big O of 1, and that's going to be incredibly quick, way quicker than big O of n. The downside with linked lists, though, is if you're not operating on the very first element, it's going to be a big O notation of n. For example, if I wanted to get the third element in the array, this 15 here, I have to start with the first element, get the next one, and then from here, get the next one, and now I have the third element. While with an array, you just get an element with the index of 2, and that'll give you the third element in the array. So with arrays, it's much quicker to get random elements in the array, but with linked list, it's much quicker to get the first element, insert at the beginning, or remove from the beginning, because you have a direct reference to the beginning of the element, and you don't have to do any shifting. So those are the big differences between arrays and linked list. And I think we've talked way too much about all of this theoretical stuff, so let's actually dive into the code and start implementing a linked list. So I just have here a completely blank Visual Studio Code project, and the very first thing that I want to do is I want to run a command called npm init, and we're just going to pass -y here. And this is going to initialize a package JSON for us, and then I want to install a package, we'll say npm i --save dev, and we're going to install a package called jest. And this jest package is going to allow us to actually do testing of our library, because the best way to make sure our linked list works exactly like we want it to is to actually test our linked list with in-code test instead of manually testing it over and over again, because that's very error prone, and if we change something else, we may break some of our older code. So having this testing library is just going to make it work so much easier. Also, we can follow test-driven development, which means that we actually write our test before writing our code. So we're going to write test, they're going to fail, and then we're going to write our code so that we can make our test pass. And I'll show you a little bit more of that as we get into the project. Now that that's done installing, let's create a file called linkedlist.js. This is where we're going to define our linked list. And we'll create another project called linkedlist.test.js. And this is where we're going to write all of our testing code for this linked list library. Lastly, I'm going to create a file called app.js. And this is just going to be where we can actually write some code to work with our linked list, print it out, and do manual testing instead of always doing our automated testing. It's just a nice way to visualize the work we're doing. Okay, so this has been a lot of talking, and we're finally going to dive into the code. So the first thing we need to do is we're going to create a class for our linked list. So we'll just say class linked list, and inside of here is going to be all of our code. And let's just make sure that we export this. So we'll say module.exports is going to be equal to this linked list, just so we can access this inside of our testing file. Now inside of our linked list, we're going to need some form of constructor. So we're going to put a constructor here. It's just going to be taking no parameters because we don't want to have any initial values. We're just going to default to an empty linked list. And this is going to have two references. We're going to have something called the head. This is going to be the first element in our linked list. If you remember from our example earlier, the head is what references our next element, and then our next and next and so on. So it's the beginning of our linked list. And then also we're going to have a length value. And the reason we're starting with this length value is so that we can actually keep track of our length as we add and remove elements to our list. And that way we can always access our length without having to loop through the entire linked list to figure out how long it is. This is just going to save us time in the future. So by default, we're going to have a length of 0, and our head is just going to be equal to null because we don't have any head yet. Now the next thing I'm going to do, you could do two different ways. The first way, which is the way I'm going to do this, is to create a separate class for our linked list node. So this is going to be for each one of our elements, which in our diagram earlier would be those rectangles where we have a value as well as a reference to our next node. And the reason I'm doing this as a class is just because we already have our linked list as a class, so it's going to keep consistency. The other way you could do this is just a normal JavaScript object where you had reference to a value, for example, and a next, and that's going to work just fine as well. It really doesn't matter, it's personal preference. So let's create a constructor here, and this is going to take in a value as well as next. So this value is like the value at that place in the array. So you just say this dot value is equal to value, and next is a reference to another linked list node that comes after it. So we can just say this dot next is equal to next. So now we have our linked list node complete as well as our linked list. Let's actually get to work on our very first method, which is going to allow us to add elements to our linked list. And we're going to start with adding elements to the beginning of our list. So we can just say here, insert at head, and we're going to pass in some kind of value. Let's just call it data, for example. And this is going to be the value that we want to insert into our array, and we want to insert this at the very beginning of our array at the head. So essentially what we need to do is we need to take the current head of our array and we need to replace it, and then we need to add a new linked list that is going to reference that old head. So that's fairly straightforward to do. Let's create our new node, which is just going to be equal to a new linked list node. And we're going to pass it in our value here, which is coming from here. So actually this is data like that. And then we need to pass it whatever the next element is in our array. And our next element is going to be our current head. So we can say this dot head. Now what we need to do is take our current head and set it to this new node that we just created. So we can say this dot head is equal to new node. And then lastly, take our length and we're going to add 1 to it. Since we just added a new element to our array, it is now 1 longer. So again, to repeat exactly what went on here, we created a new node, gave it the data, essentially the value we want to store, and we said that the next value after this element is our current start of our list. And then we replaced the start of our list with this new node. So now the reference to the beginning of our list is this new node we just created, and that new node references the old start of our list, so now that's our second item. Now this is all a little bit difficult to understand without actually looking at the output, so let's just save this as we have it, come into our app here, and we're going to make sure we get a linked list. We're just going to import our linked list. It's equal to require / linked list. We're going to create a new linked list, which call it LL. It's equal to new linked list, and we're going to say ll.insert at head. We're going to insert, for example, the value 10, and then we're going to come down here and insert at the head the value of 20. So at the very beginning, we have an empty linked list, and then we're going to have a linked list with one element of 10, and then another down here, we're going to have a linked list with two elements, the first being 20 and the second being 10. And if we just log this out, we could say console.log ll, and let's just come down here and say node app.js, and we make sure we save that file before we run it. And it looks like we're getting an error, so let's just come up here. It says length is undefined. I'll come back to our linked list. This should say this.length instead of length. That should fix it. Now if we rerun this, you can see we get our linked list being printed out. As you can see, we have our head, which is a linked list node that has a value of 20. It has a next property, which has just another one of these nodes that has a value of 10. And then the next value of the second element in our array is null because there's nothing else that comes after that. And also our length is properly set to 2. So essentially what we did is we first inserted just one element here. We can even do a second print to demonstrate this even further. So as you can see, the first time we print, our linked list just has a head, which has a value of 10 and links to nothing else. And then down here, our new head value is 20, and it links to that old head value of 10. So we're just inserting at the beginning. And as you can see in this linked list, inserted head, this is going to be that super quick, constant time running operation, because every time we add to the head, all we do is create one new element and just reference the old element. It doesn't do any looping, so it's going to be super, super quick and memory efficient to do this, as opposed to working with an array. So now that we've manually tested this to make sure our output looks like we want it to, let's actually go in and start doing some testing. And for this first example, I didn't do any test-driven development, but for future examples, I'm going to show you how to do it with test-driven development. So in our linked list test file here, all we need to do is again import our linked list, which is just require of / linked list. And then with Jest, we have the ability to write test and write blocks around them. So generally the first thing you want to do is have a describe block. And this is going to describe the thing we're working on, essentially the thing we're testing. In our case, we're going to be testing this method here, insert at head. So we can just put the pound sign here, insert at head. And this pound sign is just a convention to say that we're going to be performing a test on a method of a class. In our case, this is a method of this linked list class. You don't need that, but it's just a good convention. I like to have it there. Now inside of here, we just pass a function, and this function is going to be all of our test information we want. And if you need more information about how Jest works, I have a full tutorial on it. I'll link in the cards and description down below. So going forward, we're going to write our test, and this test is going to be testing this function, and all we want to do is test that it works. And this is just going to say here, it adds the element to the beginning of the list. And again, this is going to take a function, and this function is going to be all of our test code inside of here. So we want to first create our linked list. So we can say const ll is going to be equal to a new linked list, and we're going to say ll.insert at head. Let's put 10 as our first element, and then we'll say insert at head is going to be 20, just like that. And before we insert this new element, I want to get a reference to our old head value, which is just ll.head, just so we can make sure that we're overriding our old head value with a new head value, essentially. So now what I can do down here is I can come in with an expect, and I can say our linked list .head.value. Since we just inserted a new head, it should be equal to this 20. So we could say .to_be_20. Then I can write another test. We can just say we can expect that the ll.head.next. So the thing that our head references should be this old head value. So we can say to be old head. And then lastly, to make sure our length is working, we can say we expect the length of our linked list to be 2. Just like that. So now to run these tests, instead of our package.json, let's take this test here, just replace this with jest --coverage. This is going to give us nice stats depending on how much of our code is actually tested. And if we save all these files and run npm test, you should see that our test suite is going to run, and hopefully everything passes first time. As you can see, all of our tests passed 100%, and you can see that all of our code is covered. Every line that we wrote has 100% coverage, which is a really good thing to have if you can get there. So now before we jump into our linked list and start writing more and more methods on it, I want to first do test-driven development and actually write the test for the thing that we're going to create. So we have our insert head done. Let's just minimize this. And we can say here now we want to do another describe, and this time we want to describe the ability to get an element from an index. So we can say get by index. I'm going to prefix this with that pound symbol again. And inside of here, we're going to have quite a few different tests because we want to test what happens if we pass it an index less than 0. So let's write out that test. So again, we can put it inside of a describe block. We can say with index less than 0, because this is essentially the environment that we're testing in. We're testing this function with this particular convention. And then we just want to say test. And here we're going to say it returns null, because we want our function to return null if we pass it an index that doesn't exist inside of it. So we just say it's going to return null. So we can say linked list is equal to new linked list. And we're going to need to put some elements inside of this linked list. So you may think, okay, let's just use inserted head. But generally, when you're writing test for a class, you don't want to use other methods of that class inside of other tests, because if this inserted head function does not work properly, well then this test may break if I use inserted head inside of it. So instead of doing that, I'm going to create a simple helper function on our linked list, which allows us to create a linked list from an array of values. So down here, we can just say linked list dot from values, and we're going to pass it in essentially a bunch of values. We're going to set that equal to a function that takes in a bunch of values, and all we want to do is create a brand new linked list from these values. So we can say const linked list is equal to a new linked list, just like that. And I actually want to make sure that I loop over these values in reverse order. So we're going to say I is going to be equal to values dot length minus 1. That's our very last value. We want to go while I is greater than or equal to 0, and we just want to subtract 1 from I each time. And the reason we're doing this in reverse order like this is because we're going to be constantly inserting at the beginning of our linked list. So the very first element we insert is actually going to be the last element in our linked list. And we can just say insert at head of values of I, which is going to be essentially going from the back to the front. And then we can return that linked list. So now we can create a linked list from an array of values. So if we go back into our test here, we can just say instead of a new linked list, we can say linked list dot from values. We could say, for example, 10 and 20. And what this is going to do is return to us a new linked list with these values, 10 as the head and 20 as the second element. Now we can write our expect. We can say ll.get by index. We know we're going to pass it something less than 0, so let's just do -1. And we know that we want this to be null, so we could just test to make sure that this is null. So this should return null to us when we run this function. Now let's just copy this down, because we want to do essentially the exact same thing if the index is greater than the length of our array. So we'll say with index greater than list length. So we have here 2 values, so our length is 2. So let's just say we want to get an index of 5, for example. We know that this is not in our list, so we're going to again return null. Another condition that we want to make sure we test for, which is kind of an edge case, is what happens if we try to get the very first element in our array. That is our head element. So we're going to write a test for that. We'll say describe with index 0. We know that this is going to be our head. And inside of here, we're going to have our test, and we should say it returns the head, because we know that the very first element of our array should always be our head element. So now let's write our test for this. We got our linked list here, which has got the values from 10 and 20. And then all we need to do is expect that our linked list dot get by index of 0, the value of that should be equal to our value 10 right here. It's our first one. So we should say to be 10, just like that. And then lastly, the only other case we have to test, I'll just copy this down, is if we want to get a particular index in the middle. So with index in the middle, it returns the element at that index. So let's just put a bunch in here. We'll say 10, 20, 30, 40. So let's say that we pass in an index of 2 here. That's going to be our third element of 30. So this value should be equal to 30 here. Now if we save that and run our test, you should notice we have a bunch of failures. And if we wait for this to run a little bit, you'll see we got 4 failed tests, and it's all because there's no getByIndex function, because we're doing test-driven development. We wrote our test first, and now we're going to write the code to make our test work. So let's go to our linked list and actually create that function. We can come down here and we can say getByIndex. It's going to take an index, and then in here we're going to do all of our code for actually getting that particular element. And like I mentioned in the earlier part of this video, with linked list, you have to constantly loop through every single element to get to the particular index you want, while with arrays, you can just get that instantly. So this is going to be a slower function than if we did this with arrays. So the very first thing that I want to do is, if you remember, we wrote test where if we have an index that's greater than our list length or less than 0, then we always want to return null. So let's just check that right at the beginning. If index is going to be less than 0, or if the index is greater than or equal to this dot length, which means that we don't have an element for that, we can just return null. So immediately, just by writing this, we should get 2 of our tests to pass. So let's just let this run for a second here, and you'll see we only have 2 failures now instead of 4, because those 2 tests have passed. But our other tests here are not passing because we're not actually ever returning a value from this. We're just always returning null. So let's continue on and write even more code. To do this, all we need to do is loop through all of our elements. So the first thing I want to do is get our current element. This is going to be where we are inside of the loop to try to get the next element. This is just going to be equal to, by default, our head, because we're going to start at the head and just constantly work forward until we get to the value we want. And in here, I just want to come in and say let I equal 0, so starting at 0, which is our head, while I is less than index, which is the value we want to get to, we're just going to add 1. So we're going to loop through this essentially 1 time for each index value, starting at 0 for our head and continually going forward. And all I want to do is take our current value and update it to our next value. So starting with our head, we're going to go into our loop. Let's say our index is 2. So we're going to come into our loop. The very first time, we're going to take our current value, which is head, and set it to whatever is the next value from our head. Come back into this loop, same thing, but we're going to be having our new current values next, set to the current value, and we constantly do that until we get all the way through to our index value. That means that our current is now the element at that index. So we can just return our current. And just by writing that little bit of code, we run our test, we should see that everything passes. And there we go, we have a 100% passing test and 100% test coverage, which is great. Now, in order to show you how this works, let's go over to our app here. We can now create a linked list from values, and we're just going to say 10 and 20. That'll let us get rid of all of this code here. And if we print out our linked list and run this code, node app.js, you should see we get that same linked list from before. But the way that this prints out is a little bit difficult to actually see and read. So let's create a quick helper function called print on our linked list, which is just going to loop through and print our linked list. So we can create a simple string called output. This is going to be a string just defaulted to empty string, where we're actually going to store our output. We're also going to do the same current trick where we set it to our head value. And then this time we're just going to do a while loop. So while current, so essentially while we have a element in our array to loop through, we're going to do this loop. And each iteration of this loop, we're just going to take our current and set it to our next value. So we're just going to loop through all of the values in our linked list. And all I want to do is take our output, and I want to just append each one of our values. So we can say output, and here I want to, append our current dot value, and I'm going to add a little arrow just to make our output look a little better. And then finally, at the end, we're just going to console.log the output, output. And since we know our very last element points to null, we're just going to put null at the end here. Now in our app, instead of logging out, we can just say ll.print. And if we run this again, we should see we get 10 pointing to 20, which points to null. So it's a little bit of an easier way to visualize what our linked list looks like. So let's add a few more elements here. We'll say 30 and 40. Print that out again. There you go, 10, 20, 30, 40. That's exactly what we want. And now let's do a little console.log of ll.getByIndex, the function we just created, and let's get the head, the very first element. We should see it print out 10. So let's run that. And as you see, it prints out a bunch of stuff. I want to make sure I just print out the value of that node. So let's come down here again, and you can see we got 10 being printed out. we try to get the index of 2, which is our third element, we should get 30 printed. As you can see, we get 30. So we know that this function is working both through automated testing and through manual testing. So now the next thing that I want to work on is the ability to insert a value anywhere in our linked list and not just at the head. So again, let's go back and do some test-driven development. Let's minimize both of these. We can say describe, and we want to do insert at index is going to be the name of the function we create. And we want to have a few different conditions. And these are going to be essentially these same exact conditions here. Let's just copy this over. So we can have with an index less than 0. Obviously, we can't insert anything with an index less than 0. We're also going to have a similar check with an index greater than the length of the list, which again, there's no point in inserting something if it's outside the bounds of our list. And then we're going to check with an index of 0, essentially the same as replacing our head value. So let's just come down here. And then finally, we're going to have with an index in the middle, which is the general use case that we think this will be used for. So now we have all of our different conditions for our test written out. Let's just minimize this so we have just this section to work with. And I'm going to start with this easy case here with an index less than 0. We want to make sure we don't actually insert anything. So let's create a linked list, just like we have been doing for all of our tests. We'll say linked list.fromValues 10 and 20. And we're going to say insert at index. Let's say we want to insert at the index of -1, and we're going to insert the value 30. Now, obviously, we want to make sure that this doesn't actually change the size of our list. So we're just going to expect that our linked list.length is going to be 2. We don't actually want it to change. And we need to make sure we put this inside of a test block. So we'll say test, and this test is going to be say it does not insert anything. So now with that done, let's just move this down so it is inside of our test, and we can copy this exact test and put it down here because we're going to do an index greater than our linked list. So we'll say 5 here, for example, and again, it should not actually insert anything into our linked list. Now let's copy this again down here. We're going to do with an index of 0. So at 0, we're going to insert 30, and what this should do is update our head. So let's again create a test, and we should say it should insert at the head. And make sure this is inside of our test. And then what we can do is just a few expects. We can say ll.head.value. We expect that to be 30, since we just inserted at the head the value of 30. We can do another expect, where we're expecting the next dot value. This should be 10, since this is the value directly after our head. And then we want to make sure that, again, our linked list length has actually updated. So we'll say length should change to be 3. Let's save that and come up here a little ways and run our test. And we should again get failures for all of these. And actually, we still need to write this test down here. So let's just copy all of this code. We should say it should insert in the middle or at the given index. Let's just say that. And we'll say a few more values here, 30 and 40. And let's just insert at index 2 the value of 50. So now we can just come down here and actually get our node. So we can say node is equal to ll.get by index 2. So this is going to be the node that we just inserted. And we can just say node.value should be 50. The node.next.value should be whatever is after this element. So we're inserting here. So the next value should be 30. And we want our linked list length to go from 4 to 5, just like that. So now if we save and we run this, again, we should get failures for all of these new tests we wrote. And as you can see, we got 4 failures, which is exactly what we expected. Now onto our linked list. Let's just minimize a little bit of this and actually write the code for insert at index. It's going to take an index and a value. So now inside of here, let's again think kind of like our use cases inside of our test. We know that we wrote a particular test for what happens if we insert at index 0. Well, that's the same as inserting at our head, right? So if index is equal to 0, all we want to do is just return insert at head, because we're just calling the insert at head function essentially. That's exactly what inserting at the index of 0 does. So we're just going to fall back to this function, which we already wrote. Now, if we want to insert at a particular index, what we need to do is first find the element directly before that index, and then we need to set the next value of that element to the new value we're inserting. And then we'd need to take the value that's currently at this index and set it as the next value for the value that we are inserting right now. That sounds confusing, but I promise I'll explain it all in just a bit. So we want to get our previous element, the one directly before this index. So we can say this.get by index of index minus 1. This is going to get us the value directly before where we want to insert. And what we can do with that is first just check to make sure that this is not equal to null. So if this is equal to null, we're going to return null. Because if we passed in a really large value, for example, we're going to get null here, or if we pass like -20, obviously this is going to be null as well. So now what we need to do is, like I mentioned, we need to take this previous .next and we need to set it to a new node. So we'll say new linked list node, which is going to take in this value, just like that. And what is the next value of this? Well, the next value of this is our current previous .next. So we can just say previous .next. So what this is doing is it's creating a new node with a particular value, and the next value of that node is whatever comes after the previous index we're inserting inside. And then the previous index is saying, well, my next thing is this brand new node that I just created. So we're essentially sandwiching this in between two nodes that already exist. Now, lastly, we're just going to take our length, add 1 to it, and now if we run our test, everything should hopefully pass. And if we just give it a little bit, you can see all 9 of our tests have passed. And I'm going to show you how this works just a little bit. So we can just say ll.insert at index. We're going to insert at index 2 the value of, let's say, 60. And let's put our print right below here. And let's actually put one right above too, so we can see exactly what changes. So we can run node app.js, and you can see we have 10, 20, 30, 40. And then we're inserting at the index of 2, which is essentially our third element. So we have 10 and 20 just fine, and now we sandwich 60 in there right before 30 and 40. And the way that this works, as I mentioned before, is we're taking what the previous value here, 20, references, which is 30, and making that the reference for our new value 60, and then we're taking our previous value 20 and saying that it references our new value 60. So we're just moving around that next pointer to whatever the next element is to really just sandwich this 60 in here. And this is actually going to be fairly slow. It's a big O of n because we have to potentially loop through every one of our elements by getting the correct element before we can actually insert at a particular index. Now, the next function that I want to create is an ability to remove elements from our list, because right now we have the ability to insert, we have the ability to insert anywhere, and we have the ability to get, but we don't have the ability to remove yet. So let's create some test for removing. Let's just minimize all of this. And we're going to start by removing from the head. So we'll say describe remove at head. And inside of here, we're just going to be a function. And this function is going to have a test that just says removes the head. And we'll call this function remove head instead of remove at head, which makes a little more sense. And now with this test, we want to create a new linked list, pretty much just like we've done up here. So we'll just copy all of this code. So we're going to do a linked list dot from values of 10, 20, and 30, for example. So now we have a linked list, 3 long, and we want to just do linked list dot remove head. And what we would expect this to do is to change our length to be shorter. So our head value should be our second one, which is 20. So that's exactly what we want. And we would expect our length to go from 3 to 2. So these are both of our specs that we have, and these should look correct. But of course, if we run this, we're going to get a failure because we don't have this method defined yet. There we go, 1 failure. So let's define that method. We can say remove head. And all this is going to do is just change our head. Our head is now going to be removed, and instead our head is going to be equal to whatever comes after it. So we can say this.head.next. So the next value of our head is set to our current head, and then we can take our length and we could just subtract 1 from it. And that's all there is. If we run this, this is going to work just fine. And of course, if I get rid of this extra minus, I had too many minuses in there, so it gave an error. But now, if this runs, you should see everything passed. We could do a little manual testing too, by just saying remove head, just like this. So now what should happen is we should get 10, 20, 30 being printed, and then after we remove, it should be just 20, 30, 40. So let's run that node app.js. You can see 10, 20, 30, 40, and then we remove the head, so it's just 20, 30, 40. Now the final function that I actually want to work on implementing is going to be essentially the same thing as we've done insert a head and remove head. We did insert at index, we need to do remove at index. So let's just write the test out for this. We're going to say describe, and we want to do remove at index, with a little pound sign in there. And again, we're going to have a bunch of different test cases for this. These test cases are actually going to be exactly the same as insert. So I'm just going to copy all of this insert code here. Copy that, re-minimize this, minimize that, and we're going to paste this in. So we have with an index less than 0, we want to say it does not remove anything. And here we should say remove at index -1 is what we're going to remove. We're going to remove at the index -1. So our length should still stay 2. We shouldn't actually remove anything. Same thing down here. We can actually copy this code. It's going to be exactly the same because with an index greater than the list length, we again do not want to remove anything. Now down here, if we were going to remove the head with an index of 0, we want this to perform exactly the same as essentially removing the head. So we'll say remove at index of 0. And our head.value should be this 20 here. So we'll change that to 20. And the next should be null. But instead of being null, we're going to add another element on here, which is 30. So our next value should be 30 after our head. And our length should be 2, since it's going from 3 down to 2. Now lastly, we're going to deep down here. We're going to remove with an index in the middle. So we're going to say, let's just remove this index 2, which is this value 30 here. So what we can do is we can say we're going to get the index, the value of the index at 1, which is the one directly before the one we removed. And that should be a value of 20. And we should say the one that is after that should be a value of 40, since we removed this 30. And our list length should now be set to 3. So let's just run these tests to make sure that they all fail like we expect. And there you go, 4 failures. So now let's implement this function. We can just say remove at index is going to take in an index. And this code is going to be nearly identical to what happens when we insert. I'm actually just going to copy this down. And you can see if we have an index of 0, we want to remove the head. Just like we did with inserting at the head, we're going to remove the head. Now we still need to get our previous value, because what we're going to do now, instead of putting a new node after our previous value, we need to cut out whatever our previous value's next is and set it to its next value. We essentially want to leapfrog over the one we want to delete. So instead of creating a new node, we can just say previous.next is equal to our previous.next.next. We're just skipping over our current next and placing it with the next element. And then lastly, we can subtract 1. So let's run our test this time, and you should see that everything is going to pass with 100% coverage. But of course, that didn't actually happen. We had 2 failures, so let's see what actually failed. You can see here, remove at index with an index in the middle, and it said it should remove the given index. We expected our next value to be 40, but it actually was undefined. Now this code here looks to be correct, so I want to make sure that the actual test that we wrote is also correct. So right here, it's saying that this line is what is failing. And it looks like we never actually wrote out this test like it should be, because we're doing an insertion here at an index when we actually want to do a remove at that index. So now if we save and we rerun our test, we should hopefully get that test passing this time. And as we go, we now only have 1 failure instead of 2. So now let's move up a little ways. It says remove at index with index 0. It should remove the head, and it says reference arrow value is not defined. So this looks like an actual error in our code. Let's go over to our code. You can see remove head is taking a value. Obviously, we don't have a value when we're removing, so let's get rid of that value, rerun our test, and hopefully this time everything passes. And this failure right here that we had where our test failed and now it passed is actually a really great example of why test-driven development is so good, because we wrote our test, they failed. We wrote some code, more tests passed, but some were still failing, so we changed our code a little bit and got more to pass, changed it a little bit more, and then finally all of our tests passed. And that's really why you want to use testing and test-driven development, is because it makes it really easy to iterate through your changes. And lastly, I just want to go through here. Let's say we're going to do a remove at index of 2. Let's just print that out. So node app.js. You can see 10, 20, 30, 40. We remove our index 2, which is our third element. So we just have 10, 20, and 40. So it perfectly executed and removed the element we didn't want. And that is finally the end of everything you need to know about the linked list. If you enjoyed this video and want to see more data structure videos, let me know down in the comments below, and also subscribe to the channel for more videos just like this. Thank you very much for watching, and have a good day.